Example 17 wants us to prove an identity. So remember, identities are things that are true all the time. And it wants us to do that by simplifying one side and leaving another side alone. So if we look at these examples, so let's say the first one, it has the sine of theta plus the cosine of theta squared equals 1 plus 2 sine of theta cosine of theta. So in this case, when it says it wants you to do one side, you want to basically draw a line down the middle and pick one side and don't mess with the other side. Just try to make one side look exactly like the other, so that we can make this identity true and show that it's true all the time. You can pick either side. Normally, it's a lot easier to pick the more complicated side, because that way you can simplify it a little bit easier. I'm going to pick this side here. Now, because what I can do is I can distribute this. I can kind of FOIL this, or if you want to think about the box method, box it out, and then go from there. So if I take this side, the sine of theta plus the cosine of theta squared, so that's multiplying binomials, so I can use my little binomial theorem. I know that what's going to happen with this is I'm going to get the sine of theta squared. So this actual sine squared, not theta, so I put the 2 kind of over the n, plus 2 sine of theta cosine of theta plus the cosine squared of theta. So that's squared, and the middle term is 2 sine cosine. Well, I see I've got a 2 sine cosine here, so that's putting me on the right track. Now I just have to figure out this extra little 1 thing. Well, if you remember, sine squared plus cosine squared always equals 1. So by making that connection, I've already proved that this left side is equal to the right side. So I used some math and figured out, hey, I can turn this side into the other side kind of easily. So it's nice. So the second one gives me 7 cosecant squared of theta minus 3 cotangent squared of theta equals 3 plus 4 cosecant squared of theta. So with this particular problem, again, I want to try to take the more complicated side, because that's normally the side that I can do more with. So what I'm going to do is bring up an old theorem, or an old identity, excuse me, that said that if I had 1 plus cotangent squared of theta, that's going to equal cosecant squared of theta. Okay, so what I can do is, because I want to try to change everything to have in terms of cosecant, I need to solve for cotangent. So what I'm going to get here, based off of this, is that cotangent squared of theta equals cosecant squared of theta minus 1. So at this point, what I need to do is a direct replacement. And I'm going to have 7 cosecant squared of theta minus 3 times this side, right? So cosecant squared of theta minus 1. Now, if I distribute this, I get 7 cosecant squared of theta minus 3 cosecant squared of theta plus 3. And you can see that this is going to become 4 cosecant squared of theta plus 3, and that equals 3 plus 4 cosecant squared theta. It's the same idea. So sometimes you'll have to see and make connections and know how the different trig functions connect to each other, and maybe alter a previous identity to make another true one. maybe it's not the one that we learned specifically, but we can alter them so long as we do legal mathematics. But the idea is pick one side and only work with that side to turn it into the other. That's the first step. Now, identities can be done with both sides, but with these examples, you just want to pick one side and work with it.